Newton's equations, second video. Let's consider the same graph as before with an initial speed and an increasing speed up until this final speed after a certain time. This time, instead of considering the area under the curve as a triangle and a rectangle below it, let's consider it as just one area. Shading this way, you will recognize the shape of a trapezoid. So therefore, if we look at the formula for a trapezoid, we have area equals big base plus small base times height divided by 2. Now, if we look at the graph, we have a trapezoid lying on its side. So the small base would correspond to the initial speed. The large base would obviously correspond to the final speed from 0, and the height would correspond to the time. Therefore, we get the following formula. Hence, our second formula to express Newton's equation, delta D equals Vf plus Vi times delta T divided by 2. So therefore, if we look at example number 2, a car traveling at 10 meters per second reaches a speed of 25 meters per second after 10 seconds. What distance did it travel? Given required solution. So we restate our given this way. We're still looking for the distance traveled. We put in our values as such. You will see that 2510 is 35 meters per second. The second units cancel. Again, we're left with the proper unit of meters. And we have 175 meters, which corresponds to the answer we had from the first example in the first video. So therefore, you can see that we can solve the problem. Instead of using our formula, which had represented a triangle and a rectangle, we solve with different variables as a trapezoid.